standing. Flag no fail. Hold strong, people. Hold strong. Revolutionary. Frontline standing. Solitary. Mind state. Kinda scary. Take a deep breath. Take a deep breath and put me on the front line. 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 Hold strong. I'm battle tested. Hold strong. I'm battle tested. Hold strong. I'm battle tested. I'm battle tested. I'm battle tested. Hold strong. I'm battle tested. Hold strong. I'm battle tested. Hold strong. I'm battle tested. I'm battle tested. I'm battle tested. Follow me until the end. Follow me if you can. Heart beating faster. Don't forget to breathe and put me on the front line. 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 Hold strong. I'm battle tested. Hold strong. I'm battle tested.
What is up, people? So this is what we're gonna do. We're gonna do doing a small little debate, more of a discussion over on the Discord server. Figured it'd be fun to go ahead and live stream it and have it up on for upload. Let me see. The people of Earth. And I don't even know who the hell you are. So I wouldn't block you. You're good to go. I don't think very many people are going to be here, so you enjoy talking with yourself. With that said, let me go ahead and move over to the Discord. Those guys are over there waiting for me right now. All right, guys, what's up?
Nothing. I'm talking about Colorado.
Cool. All right, so we're live. So let everyone know. Got some people. So till we start, let me see. Get over here real quick. All right, we're good to go.
Awesome. Yeah, we'll touch back on that in a little bit later, Chris.
Okay, I have to show you what I'm talking about to make a little bit more sense.
Yeah, cool. Yeah, just get that prepared. We'll look at that. We'll look at that in a bit.
Yeah. All right. Yeah. So, Koso, we're good to go. Ready to do it.
Yeah, we're good to go. No, I just wanted to preface that I'm going to be. I'm headed to Whataburger actually to get a burger, but it's not going to. It's not going to get in the way.
I mean, no worries. I already let everyone know it's more of it's a debate, but it's a discussion, really. We're not getting too heated about anything, so the bullshit and banter can happen. No worries at all.
Hey, man, I may get heated.
But it happens, you know.
Never said no getting heated.
Well, I'm just saying, you know, when you start realizing that the globe is fake, you kind of get upset. I understand.
You saying that got me heated. Yeah.
Perfect. Nothing like an angry Glober. At least I know you'll be trying this time.
I tell you, man.
So
what's the closest map that you accept as the flat Earth map?
Chris.
Well, the problem is I'm not a map maker, so I'm not gonna give you a map that I run with. I definitely don't run with a globe map or the 6 projections that they have.
And he's recording right now, I think, also, or he's streaming this live, so that's
yeah.
That's how we're gonna have it.
A little bit more structured on that one.
Yeah, just slightly.
But like I said, I'll give you guys time to add in, so you're not just sitting there the whole time. But yeah. I mean, okay, so you kind of wanted me to just kind of go in on it, right?
Yeah, if you could just I know you said, I don't know what you maybe you had a you did have a question earlier, and if you don't have that question anymore, yeah, just whatever. We'll talk about that first, and we'll see where it leads us.
Okay, cool. Yeah, I think I was referring to quantum theory and all that good stuff that we were talking about last time. It was about trying to find where we left off. Okay, I was taking notes then too. Okay. So basically, I was actually came across some notes that I was looking at before, and kind of one of the things that jumped right out at me was the fact of basically what the whole quantum theory would bring to how science works, I guess you would call it. And usually, usually when I ask about quantum, I kind of get stutter steps and back pedals, but with you, you actually have a conversation about it, so it's not that bad to bring it up and not expect anything. But when I was looking at it, they were talking about if they started using quantum, the vacuum of space would actually have to have a matter, I guess you would call it, energy. Um, do you think that's why, for one, that they don't use it?
I have to say, because my phone cut out for a second while I switched the Wi-Fi off. I did hear that you said if they switch to quantum mechanics, the vacuum of space would have to have some kind of energy in itself.
Yeah,
And you're saying that's why they don't use it.
yeah. That's
Um,
it. That's it.
what do you mean by them not using it?
Um, well, right now everything that is basically based off of the relative or special relativity and all that good Einstein gibble. Um, but with the finding of quantum, because what I was reading on it basically was because what I always assumed was with quantum, uh, things like average day gravity, uh, the way just speed of light, everything is measured or even predicted would change. But then when like I said, I found some more notes that I had in the past, and one of the things that was I had in bold letters basically was, um, as of right now, the theory is basically that there is no energy in the vacuum of space. Correct?
That's correct.
Okay.
A vacuum generally, I know people
Yeah, it's not.
they say it's just complete void.
Yeah. Okay, I'll start saying that because it does. Because some people who don't realize it will think fucking Hoover. It's just almost a waste of fucking time. Um, so basically, in the void, if quantum is used, then all of a sudden everything changes, right?
No, it's not quite. I want to clear something up,
Yeah.
which may save a bunch of time, because I've had this discussion with a lot of people talking about the subject about quantum mechanics and general relativity and special relativity, and the claim that it's well known that they don't work together or that they don't exist together or whatever it is. That's that's not entirely what the claim is. The claim is that like when Einstein made it when he came up with relativity and general relativity, it was great and it worked at the time, and they find it still works. It works all the way. But then they started getting into quantum mechanics, and they started finding things out. And at this point, like at this stage with quantum mechanics, they're confident in their understanding of it that they're trying to make a general model of the entire universe. I think it's actually the standard model. Sorry, of the entire universe based off of like 16 or 17 particles, subatomic particles, uh, and so they're trying to make a model that works with both what's called
General.
quanta, and then also with quantum fields. And the only thing that doesn't go along with that is gravity. So it still works in every way that they use to test it. It's just for gravity, they go ahead and they still stick with general relativity and special relativity.
Well,
And so,
also, it's also the energy in the vacuum, void of space.
yeah, but so when I say quanta and then the quantum fields, these quantum fields exist I'd have to look real quick to make sure that they exist almost everywhere. They're not just fields surrounding the particle, but they do. They're supposed to be. They're supposed to exist everywhere. But these fields do nothing. All they do is they give these
But
quanta relationship to, you know, the space time, or the, the realm we live in.
but
But
wait. If you say it says it's nothing, but that's where we're seeing all these photons disappearing and appearing at random, just inconsistency. Everything like that's why I was bringing it up as it confuses them with what they know now, because there's things they're seeing, there's things that are happening that they weren't seeing before or weren't having to take into account. I guess you would say.
it's like photons disappearing and reappearing.
Yeah,
They don't.
or particles. I'm
Yeah.
sorry.
So basically, you're probably just referring to quantum principles on their own. That generally doesn't happen. Like photons disappearing and reappearing and all that. It's just a lot of quantum mechanics. Uh, it's extremely uh, unintuitive properties of these subatomic particles, and it's not that they randomly do this or that. It's just that we we're incapable of measuring what it is that they do, to the point where what they're doing actually appears to be, uh, you'd say random, but it's a hard to describe them, because like with say the uncertainty principle, for instance. It's like they can't measure the electron's velocity along with its position, and so it's really just the lack of the ability to measure these things. But that's what I'm saying, is that these two descriptions, both the quantum field theory and the theory of general relativity, special relativity, they both work, and you just need both of them to describe these things. And so you just measure them differently, basically. But that doesn't mean that in space, or I'm sorry, in a vacuum, that there's an energy there, that, because energy implies both. Yeah, it implies more than is that there's no energy in a vacuum. Like there's not, at least as far as the general or the standard model suggests. You have to introduce these subatomic particles to get that energy. But yeah, okay. I'm sorry. I think I'm missing the question. Maybe
Well,
I didn't answer.
no, you pretty much got it spot on. Pretty much what the question was, but the things that I'm seeing, the things that I was researching and seeing, kind of says different though. That's kind of where, because like you're hitting on parts, but then after a second or two, you kind of were voiding off of it. Um, like
Could
you
you
were
refer to that?
say again.
Could you refer to the what you're talking about, or like
Like
the
oh
particle?
okay, oh, I'm sorry. Like the measurements, in the scale. Like I understand that part. But with that becomes the fact of that's what I was talking about, the energy that's in space. Uh, with relativity, we're not really there's not too much activity happening, nothing really going on in that void. So to say there is it's no mass is easy, but with quantum it changes that. It changes it. That's why I don't understand when you say they work together. I don't understand how they would work together if one shows uh, no energy happening, but quantum. I mean, it's just we see everything.
That's Yeah, I know, but that's I think it's not that one shows that they have, or that. Okay, so yeah, it's not that one shows something different and the other one shows something else totally different. They're both describing two different things, or describing things in different ways. These two different theories, and so general relativity and special relativity. You work with light, you work with space time and gravity, but you're not working on the subatomic realm. And in that realm, just because of the size and the mass, um, and the sometimes massless objects, um, they do just strange things. So things that have no mass are generally known to go the speed of light, or that constant speed, and that speed's not it's not negotiable. It is a constant speed, and it hasn't changed because of either theory. Like either theory, both, you know, they suggest the same thing as far as that goes. and mass, it doesn't change. And so it's like with let's say with a vacuum or whatever, it's not that there, like if there's a vacuum, there's no mass. So if you were talking about an electric field, electromagnetic field, it would not have properties in it that would give any energy or any mass or anything like that. It's just only a way to describe what the photons and how they travel through it. The photon would be what would give you the energy, no mass though.
But they can't.
Um,
But but how would? But see, that's what that question. How do they? If they can't measure it, how do they say it's not there?
no, it's not that they can't measure it. It's that they're measured in different ways. And what do you mean specifically that it's
Well,
not there? Like the
like for
vacuum in a
instance,
vacuum. Oh, you're talking about the field, like a
yeah,
field.
yeah, yeah. For instance, right now, like one of my notes that I'm looking at, it says quantum field theory also can't figure out the measurement of energy in the vacuum of space.
Okay. Yeah. Maybe can you link what you're showing, what you're
No,
looking
no,
at?
I'm looking at my notes right now.
But I'll give you. Oh, it's okay.
Yeah, yeah.
Can I please say that I'm
Yeah.
here?
Yeah. What's up,
What's up?
Gorgon?
How you
I
doing,
saw
sir?
that you were here. Yeah. So let's just talk about space time for a second, and my understanding of these different fields, because I was always confused why, and I know why actually. It's because it doesn't weigh the same way there's measurements they don't expect to cope with quantum field theory. But if you think about it, the space time in itself is a field in which gravity
Mm,
kind of operates in.
space-time is kind of a theoretical idea, I guess you would call it.
Exactly. No, no, yeah. Well, no, they're all theoretical ideas, but space time is not a concept. Space time is not something that you can touch or that you can measure or that
No,
you can do this and that. Space time is something in which other things exist in, and gravity is the relationship with those things
like the
and
group.
this other thing, space time. And so, like when we say fields, we're not talking about something that is in itself measurable or in itself uh, observable. It's only how the whichever force we're talking about would act in this field.
The subject. It's a how do you say it?
An arena.
Yeah, it's where things happen. It's not what.
Yeah,
Yeah, I
it's
no
only it's,
no no. I get what you're saying. Yeah.
oh shoot. There was two lanes here behind the wall. Sorry, go ahead. I'm sorry.
Yeah, no worries, no worries. No, you're good. Like I said, man, we're just saying we don't need to be all super structured. I mean, structured is definitely where we want to be, but I'm not expecting it to.
I'm glad to talk about this quantum mechanics, man. But I mean, because I really am. But if
Anything.
you have anything specific, the other debate I was in, that for some reason they didn't want you to link stuff. But if you have something you can link it, let me know so I can read while you're talking.
Oh yeah, yeah, no worries. If I do, I'll
Can I
go.
recommend Stephen Hawking's A Brief History of Time?
Yeah, we're gonna go
That
ahead.
attempts
I,
to
I,
explain it, but I didn't get it.
I don't think we're gonna have time to.
I have like 3 copies of that book. So I have like the visual one too. It's a really good, it's a cool book.
I have to think they got it on audio. I don't
No,
have
I don't
time
have
to.
it on audio, but I have like the paperback hard copy, and then I have like the hard copy, like one with pictures, and that was awesome.
Man, it's 2018, man.
Yeah, I listen. I usually listen to audiobooks now, but that was back then. And also, my ex really hated fucking. Excuse me. Yeah, she really hated audio or
You
me
can
listening to like podcasts and
cuss
audiobooks.
all you want, man. I don't care.
All right.
I don't mind at all.
I've always wanted to say that.
I didn't.
Buggers.
You stupid ass.
Just kidding.
Yeah, I mean, I was just kind of feeding off what we were kind of talking about before. I mean, this conversation can go in any direction. I don't really care.
No, yeah, but honestly, because I'm learning at the same time too. And I've learned with getting in these debates or talking about flat Earth, globe Earth, whatever. You end up learning a lot,
Yeah.
even depending on what side you're on. Doesn't matter.
Oh, well, that's shit. Yeah, man, if you saw my stack of notes, it'd be crazy. I have taken notes pretty much from day one.
Yeah.
So, can you expand on what? Okay, so I know I talked about the fields and all that, but what else did you mean by the like the vacuum in itself having intrinsic I guess energy or something.
Well,
along those
Yes,
lines.
it
well,
does.
hang on. So basically, what I was saying was, or what I've been researching on it is the way everything is now, as is, with relativity and all that good stuff, and how we measure uh, the energy or the mass in the void of space. Um, right now, as I guess you would call it, we call it a zero, right? We're way we measure vacuum of space is zero energy, zero mass.
Yeah, so I guess you're referring to 0 point energy, or
Yes,
you're just
yes, 0 point energy. My apologies. So basically, what I'm at, like, maybe I'm more wanting to know, rather than saying I know, but I don't get how one right now we have a 0 point energy, but with quantum and all of a sudden we have what was the fucking number? It was like 10 to the second. It was some fucking weird fucking number. I don't see it right now, but it basically goes from nothing to a whole lot of something. From what I'm researching on it. If I'm wrong, correct
let,
me, please, because I don't understand how the two
let
differences
me
are.
yeah, let me explain. I used to have a book called Feel. Actually, it's really funny because the cover of the book said Einstein was wrong. I'm like, what the fuck kind of idiot would say that? But then I met. Well, no offense, by the way. No offense to anybody who thinks Einstein's an idiot. But
Oh,
it's
I'm
just that was
gonna
kind of the
ban you
first time.
now. No, I'm just kidding.
No, that was just the first time I ever seen that like exclaimed, especially on the cover of a book. But I've heard a lot of people who really don't like Einstein. But regardless, I was like, I'll read this thing. I'll read this book. But it was a book about quantum field theory, and it was called Fields of Color, I think it was called. And so it describes, if I remember correctly, it described quantum mechanics. And so instead of thinking of all these quanta of like photons and even matter itself, instead of thinking of these things as something that exists in a space like a physical object that you can touch, it imagined that everything was just fields basically. Like they were all fluctuating fields that at some point or another, like when you observe it, for example, they would then, or only for that moment, uh, be in a position, like I said, that you could measure. And that also goes along with Heisenberg's uncertainty principle with the electron, like not being able to measure its speed along with its velocity. Um, and so, yeah, I, if I remember correctly, I think that's why those two theories don't cope together because they're talking about two totally different things, and I'm certain that some smart guy, maybe another Jew, just like Einstein, is going, a young guy, maybe me, I don't know. I'm just kidding. No, but somebody is going to really expand on gravity again, like Newton had come up with it, and then Einstein had expanded on it for the first time. And I think someone's really going to expand on it in such a way. It was just described in a way that doesn't cope with the way that quantum field theory is trying to describe everything. If you give me just a second, I have to order my food now.
In other words,
But
if
no,
it
no, but that's what I'm saying. They describe everything as a field, and it just doesn't work. Uh, it doesn't work that way as we think of gravity. So it's hard to even imagine. But it's like kind of like imagining if there was just fields, like kind of like the way you imagine light as like a field of photons, whatever, or a wave, And it's just like all these waves are going everywhere, and there's not really anything tangible until you observe it or measure it. It's really quite strange stuff.
okay, I kind of actually understand exactly what you're saying right now. I think. Wait, yeah, go ahead and do what you said. You had to go do something real quick. Um, if anybody wanted to add in.
Well, I can still hear you.
Oh, okay. Well, I kind of wanted you to keep going on it because I'm getting a better understanding of where you're coming from on it. Because like I said, when I'm reading it and I'm seeing and I'm trying to take it all in, I'm not seeing these two separate things. I'm seeing it being one, or I'm seeing, best way I can explain it is I'm seeing a method of explaining things and another method that overlaps it and makes that first method not make sense. And for when you say And when you say it's two separate things, I kind of would actually like you to elaborate on how it is two separate things.
Well, before I do that, because I still have the order, I
Yeah,
haven't
yeah,
ordered yet. And
yeah. No worries. I
I
was gonna.
want you, and I just want to see where they don't cope, because you said we both agree that they're two different things, and but how do they overlap in such a way that doesn't cope with one
Well, what we were just talking about, energy, energy in in the void, um, the way we see photons and particles reacting, uh, which would obviously change a lot of things. Gravity in itself, I mean, it would just destroy what is gravity now, right? That's what I read on it. So if it's that way, then how is everything that we know now not gonna just be changed by quantum? Um, the things
You
that
might.
hang on, well, I was gonna
you
let
might-
me just add this last part, and then I'll let you go ahead and say some add in. Because of those things, and then you go into like dark matter and all these things that it just to me just seems like science is going, hey, look at this, don't worry about that, look at this, don't worry about that, you know what I mean? And I could be wrong, that's why I kind of want you to explain it a little bit better to me so I get a better idea how it is.
Okay. I only heard the last of what you said because I ordered a burger, but
Oh,
it
no, no.
sounds I kind of know I've heard that before. So I think you were saying like they're just jumping around because they're wrong and they just want you to look in the other direction or something. But the
Well,
truth is,
what I was saying is basically, like you're saying, it's two separate things, but in my research, they overlap. But it feels like when there are certain things that are brought to us from by science that is kind of just more of a look at me, a show rather than the reality of what's happening.
say that last part once more. I didn't
I
understand.
just don't. I just feel like they're not giving us the full story, and they're showing us something that I guess they would think makes sense, but in reality, there's still so many holes that need to be explained. That make
Yeah,
any?
you say so many holes that need to be
Oh,
explained.
okay.
Well, I'm
Oh,
telling you, no. But I just want to say this because when I was talking about Einstein before, like this is like one dude, and who knows? There's controversy over how he wrote those papers, but he wrote like 4 or 5 papers. I think four, maybe five. I don't know, four, but he wrote 4 papers. Um, 1 year, and they're all fucking great papers, and uh, he came up with this stuff that I was thinking about this the other day. It's like nope, like there's no way that you would have come up with because we were talking about relativity and like time dilation and it's kind of weird concept that seems impossible but is actually true. About two people observing time differently and stuff like that. And it's like, yeah, he came up with this idea and he what was I saying? But yeah, so it's not a not. I mean, it is a novel idea. It's a completely novel idea to the point where he made the model for it, and that the measurements are correct. So what he said is correct. The measurements are correct, but our way of understanding it are based off of what he wrote and how he wrote it. And quantum field theory, another one of my favorite physicists, is Richard Feynman. But another guy who very simply, sorry, another guy who very simply gave us a model of everything else that fits together very nice. But these are two different people, both very smart. But it's really the issue is not that they're like subverting or distracting from of what they came up before, and they're trying to make two guys, or not. I don't think it was just Richard Feynman, by the way. There's probably a few other people also, but the two separate theories put together uh, on their own separately, try to make them merge together. And the issue with that is there's such it's just the crazy. No, I'm telling you this right now because I can truly claim this. Nobody would ever have come up with that, like with the theory of relativity, it's special and general relativity. Like it's crazy stuff. You know what I mean?
but see,
And
that's the thing though, because when that was happening is when this quantum was kind of like, oh shit, and like I think I told you before, Einstein and I forget the guy's name. A couple of his other associates were part of the board and kind of skirted that shit under the rug.
You mean, yeah, he didn't like quantum mechanics? No,
Yeah.
he didn't. He didn't agree with it, and he didn't agree with it at all for like 20 or 30 years until he started accepting because once tests and nuclear bombs and things like that, engineering proves the assumptions made by a couple of mad scientists, then you have to accept it. But before that, he was on the same page as everybody else. The same kind of people who were thinking he was crazy whenever he came up with his theories. He did. He thought those were crazy theories, and he didn't accept them until they found out that they were real. But that's totally, if you, that's okay. Sorry. No, that's exactly what you would expect from anybody, from any smart person. Actually, anyone who's skeptical of something that seems unbelievable, until proven. Thank you so much. Is that's the proper way of doing it. But that doesn't mean that just because he didn't agree with it right away doesn't mean that it's not true. It doesn't mean that it's something that's pretend. It just means he was in the same boat as everybody else.
Yeah, but my question would be, what did Einstein prevent from? Like, for instance, the Bell theory. I know the Bell theory is wrong, but I mean, Einstein did put a, a, a bit of time into making sure no one heard his theory, just based on the fact that it was against his. And when I hear that, it makes me feel like, well, what part of science was pushed through and just used because of that kind of reason? And in today, why we're not going to hear about this until 50 years from now, but what's being pushed out of the way now so that some scientists' ideas aren't going to be heard?
Yeah. But science doesn't work that way, though. Sometimes engineering works that way, or sometimes maybe theories might work that way, so you don't hear a theory that might have been heard. But science, even if you disagree with somebody else's science, you want to hide it or whatever. If your science is not true, it'll be seen. If it's true, it'll be seen. You know what I mean? So, I can't speak on science that was hidden, but the science that's been shown and it's been plenty of people have tried to prove Einstein wrong, or whoever else, and they failed. And
Well,
like I said,
Edward Hubble, he proved him wrong right off the bat.
you said Hubble, or
Yeah,
with what
Hubble.
experiment?
Yeah,
Oh, Hubble, with
Hubble.
what
Yeah, yeah.
experiment?
What is with the
Oh, you're talking
probe?
about the
Yeah,
universal constant?
yeah.
Yeah, well, he changed that. Like, his theory wasn't wrong, but he just took that out of it, and his theory was just as fine. He just took that one little piece out of
Oh
it.
no, his theory was wrong. He said his theory was that it would become static at some point.
Yeah, that was an assumption based off the observation, but the actual theory itself wasn't incorrect. It was just his assumptions based off of the
But that's what I
of the
mean, though.
information.
How do they observe us the universe slowing down, and in reality, it's expanding rapidly?
Speeding up, yeah. You said how do they what was the
How
question?
did Einstein? How did they? Yeah, obviously, it was more than just Einstein. How did they observe the universe to be at some point become static, and in
No, no,
reality,
no. But that's the thing, though. They didn't observe it to
oh,
become
well, I'm
static.
sorry.
He assumed.
You said observed. I'm sorry.
Well, I didn't even know. No, Einstein had made assumptions based off what he knew about the world and based off his theory. He assumed that it would become static, and if it became static, he had this constant. But it doesn't become static. It actually is expanding all the time. But that doesn't change the validity of his theory. That just made him have to. He just had to omit something,
Well, what would
change it barely, but
well,
it
see,
doesn't change it.
so that right there would be my point. What gave Einstein the idea that it would become static?
It's just a basic assumption. I mean, just the assumption that everything would lose What do you call it? Newton's whatever it's second law of thermodynamics, whatever it is. That uh, basically, no energy is lost. But then, uh, what was it? What's the fucking theory? What's the one
But
where the energy is eventually gonna like the entropy and all that? It's gonna
yeah, it's
cause.
a second law
Thank
and
you.
natural.
Yeah, go ahead. You go ahead.
Well, second and third, but yeah.
Heat death of the universe.
Go ahead. Go ahead.
Right.
Go ahead. You've been wanting to talk for a second. Go ahead.
Yeah, I'll just finish it and I'll let Gorgon say what he's gonna say. I was just gonna say that, like I said, things that they don't understand now and that they didn't even know of then, and like I said, these are just terms, but dark matter and dark energy, these are things that weren't known back then. This phenomena of expanding universe,
Okay.
accelerating, wasn't known back then,
They're
and
not.
so
They're,
that's why that's an
dark
assumption.
matter and energy. They're still not known.
Yeah, no, that's what I'm saying. I said the terms. I'm saying the terms. I said these things that weren't known even back
Oh,
then.
okay.
These terms that were introduced. This phenomena of the expanding, accelerating universe wasn't known at that point. So that's why that assumption was, just basically. It wasn't just an assumption. It was kind of like a. It was an assumption thinking the world worked the way we thought it worked. So, but like what we're
But it was
Yeah.
But you got to remember it was an Einstein theory though. It wasn't just an idea or something he threw out there.
no, no, no. No, I'm saying that the theory of that theory is based off the law I was telling you about thermodynamics.
Oh, okay. So that's what he was basing it off of. Okay, I get
Well,
it.
that's what he's basing. Yeah, that things would eventually, like the great cooling, I think they call it or whatever. Or I think that's
The
what they
heat
think
death
now.
of the universe.
Say it
Yeah,
again.
right. The cold, small, slow death or whatever they call it.
Entropy just stops.
You want to add something? I wish you would
I've
change
forgotten
your.
what I was going to say.
Jesus.
It's been so long since I asked, I've forgotten what I was going to say.
You gotta write that shit down, man. Fast-paced
I don't
world.
really have anywhere to write it down, and when I write stuff, I can't understand what I've written. My handwriting's that bad.
I can't help you there. That's your personal problem.
Yeah.
See, but that kind of puts it into exactly where I'm coming from on everything. Um,
Oh,
Science that we
I
have.
remember what I was going to say.
Go ahead, and let go.
It's the stuff's called dark energy and dark matter because what it is hasn't been illuminated by science yet.
It hasn't been
Right.
identified either.
No, that's what you mean. That's the thing, though. It may not be energy or matter. They don't know what their they don't know why their measurements are off. It could be because gravity is not completely understood. It could be because there's matter that we don't yet understand. They're just like placeholders in place of not knowing everything because we don't know everything.
But
But we'll figure it out.
isn't that matter that that they don't understand or know same thing that is in that changes the nothing 0 point of energy?
No, like I said, that would also be an assumption. Any description about it would be an assumption. The only thing they can do is try and figure out what's going on. Could be maybe the machines are all messed up. That's probably not the case because they're getting these measurements every time. But yeah, so they just got to figure out what's going on. It's because they understand gravity. They understand every other phenomena.
No, don't do. They don't do not understand gravity. They're still trying to.
Yeah,
How do they?
to an extent.
Okay, to the same extent that Einstein understood the universe.
Yeah,
Because
yeah, they understand it. They understand it more than a baby or a layman's person. They understand it more than any other animal at all. They don't know it like they don't know every single thing about it, and that's where the problem is. We don't know every last detail, and there's details that are missing.
okay,
But we understand.
I guess the best thing I can ask is in 50 years, with the way science is and what they know, could gravity be something that they didn't think it was, and it could be something not be what they say it is now?
Like I said earlier that it would be expanded upon. When I
It could
use
be.
it, when I use it, I say it's mass's relationship with space time, and I don't think that I don't think that really will change. But yeah, I think it could be very much. It could be understood much differently than it is now. But there's all the aspects that we know of it. I don't think will go away, like the measurements that we take now and the understanding of its relationship with mass and its distance and all that kind
Um,
of stuff. This stuff I
can
don't
I
think will change.
give an analogy? It's kind of like getting one of those trick puzzles where you can put it together in a certain way and it makes a square, and then you get another piece and you have to rearrange it so it makes another square. It's like that.
Yeah, but the problem is what happens when the end result's a circle.
Well, I don't think it will
Then
be
you've got to try and make a square out of it.
That's
because
but
the measurements work nearly every time. Like, hey, gravity's not. It's not something that's we know. But I'm not saying that you said that, by the way.
no,
This is what I'm saying. But the truth is, it works in almost every single aspect of everything we measure, except for this missing. Like it's either missing mass or it's missing missing energy of some kind.
or a whole force altogether, like for the universe.
Yeah, it could be.
Well, see, that's what
I
I'm
mean,
saying though, because let's just say I don't think any of us will live. It happens, but figuring out what that force that is expanding the universe, I mean, it obviously isn't gravity.
I think there's dudes living that were living from before World War One, even probably right now.
Huh?
And
Oh,
there's probably a dude that's still alive.
okay.
But yeah, I think people will be living to like 200 years old. People are living right now. So I personally think, I think that maybe we'll be able to create suns on this Earth. And when I say suns, I just mean nuclear fusion reactors
Okay,
in the next 20 years, 20, 30 years.
Oh, they got patents on
Uh,
it already. I wouldn't doubt it if they already did.
No, well,
Artificial sun, absolutely.
well, not artificial sun, but just nuclear fusion reactor. Uh,
Learn more.
and
They have
they
a
do.
fusion reactor, except it takes more energy to run
Yeah,
it than
exactly.
it gets out of it.
It's not energy efficient. Um, and it gives you such little energy compared to the giant machine in California and whatever.
It, it's actually you have to put more energy into it to get it started than you get out of it from running it.
Right.
See,
So it's not
that
worth
would be the
anything.
whole point of having that artificial sun. For all we know, the artificial sun is a much better. Because when I found out about the artificial sun, I tried to figure out why would you need artificial sun. Then it unfortunately took me to the rabbit hole of Hollow Earth, and then it makes perfect sense why you would need. Problem is I don't Hollow Earth, so.
Yeah, but that's what nuclear fusion is basically. It's like an artificial sun.
It's the same process that happens in the core of the sun, fusing hydrogen into helium.
Well, the idea of what happens in Earth. Things they can't see, things they can't do. They can have an idea about it.
Yeah, but a detective, a really good, like Sherlock Holmes. I used to love reading Sherlock Holmes. He was never actually at any of those crime scenes when the crime happened. But knowing everything he knows, he can deduce what exactly happened, like way before anybody else.
Yeah, but he never
shit about footprints and shit.
But the thing is he never solved a crime without ever having to go to the crime scene, without ever having to know who.
He went to the crime scene and he examined it. He just wasn't there at the time of the crime.
So who has been to this? Who has been anywhere near able to see the core of a sun?
That's the thing. We don't have to be at the core. To understand the properties of all these different forces going on. Okay. Like they know the forces that would need to be available. They know the size of the sun. They know the forces that size would imply, and they know the forces that would need to be that there would need to be for fusion to happen.
But see, how do they? Go ahead. I'm sorry. Go ahead. I thought you were.
No, I was just gonna say. People say that these are assumptions, but these are very educated.
An educated guess.
Yeah, I like to say that, but I don't like to say guess or assumptions, because some people use that as a guess or something. But it truly is an educated guess. But here's truly educated.
But the problem is, when you say something like that, the first thing that comes to mind is they're and let's not even use guess, because they're not just going, hey, let's say this. They're crunching numbers and the whole good ideas. But the problem is if they can't understand why the corona is so much hotter than the sun itself or the surface, how do they understand what's happening inside?
What they do, like I said, with any scientific theory, I know you know this. I'm not trying to be pedantic or.
I know, that's cool.
I'm just saying that with the scientific theory, they first make. I use the word educated guess because it's not just a guess; it's something that they theory. Like
I'm just thinking.
Hang on. Let him. No, hang on. Let Costa finish.
So it's it's this guess, and they put it together, and then they come up with this theory, but that theory is not, like some protected sitting on a shelf somewhere. It's something that's being bombarded by people trying to disprove it all the time. I'm trying to and all evidence and all information that all new information goes to either prove it or disprove it. So if they find something else that doesn't cope with it, they know that that theory that there's something wrong with it, or they search for reasons why there's something wrong with it. So
Okay, so you can
I forgot
almost
what I'm
say when they're saying how the core of the sun works, it's they're just they're they're throwing out ideas at the moment that can be adjusted and change the whole like that. You mean?
based on new information. Yeah.
Okay, so then there is a complete understanding that the idea of understanding the solar system, the universe is far fetched.
No, it's fluid. It's fluid. That means that it's not like it's set in stone. It's just that because we've been doing it for, we'll say 400 or 500 years, but we'll also say 2,500 years to include everyone who's been doing it. Um, but all information that's been collected in the past 400 years, it either copes with it or it doesn't cope with it. In which case, they figure new shit out or new stuff out, or it keeps happening the way they think that everything keeps working the way they think it's supposed to be working. And so these ideas, like I said, they're fluid, but they still solidify, but not to the point where they're not malleable,
Okay, but
malleable.
if we find that, for instance, we find that the void of space has a lot of energy, has mass. If we find that uh, this force, whatever this force is that is making the universe expand, you're saying that finding these things out wouldn't change everything?
No,
Oh,
not change everything. I'm gonna use an example that this guy, German dude, keeps giving to me, like a crossword puzzle. It's like if you look at all the theories in science and everything in the world the way we know it, it's like a crossword puzzle with all these different words. And sometimes new words have to get fit in, but it's never gonna be the point where you find a new word and it just throws away all the other words that fit into place because everything already fits together so well. So it's like the way we understand things, it's not completely off. It's just that, and it might, maybe you might have to think about it in a different way for it to be. The quantum field theory is kind of a different way of thinking about things, but I don't think that that's going to tear apart the way that we understand everything else. It just might have to. It might. And that's what quantum. That's really is with quantum mechanics and quantum field theory. It really is kind of. It forces you to think about things in a different way, but it doesn't tear apart everything else. The way we know things. I'm sorry, by the way. I know I was eating and the Waterburg, but my attention's off right here right now. And Gorgon, you feel free. I'm actually gonna go over to the chat so I can see when Gorgon wants to say something, and I'll just be quiet for a second.
yeah. About the corona around the sun being hotter than what scientists would say that it should be, and you're saying that they can't know what's going on inside the sun because of that.
Yeah, I'm saying.
So, like, can you please? I'm not quite getting the logic behind this. So, can you please elaborate on the logic?
Okay, so science believes in the core of the globe would be a ball of magma. They don't know there's a ball of magma. They can't see it. They theoretically think it's there, hypothetically.
Mhm.
So how would they be able to know what the core of the sun?
Because they don't necessarily know this philosophically. There is no such thing as knowing. I don't know if I exist, but I've
Oh no,
got
you do.
good
According to
evidence
Descartes, you do.
towards it. I've got good evidence towards me existing.
Well, Descartes said that. I think therefore I am.
So what
Yeah.
is this? What is their good evidence of what's happening at the core of the sun?
I'm not sure of the exact evidence, but considering what science has gotten us so far, I say that these guys in the lab coats know a lot.
Wait, say that last part again.
The guys in the lab coats tend to know a lot.
Well, all you gotta do is know a little bit more than the guy standing next to you, and you look like a genius.
Yeah.
And Gorgon, I just want to say, I just want to apologize. I didn't mean to. I'm just being a little. I'm being a jerk a little bit when I did that. But it's just because, and it's more true of what you said is that's the only thing that you know, and that's what Descartes was kind of saying when he says, "I think before I am." That's the only thing that you can know is that you exist. Everything else, though, you're right. You don't really know it. But the same thing, but to an extent, like same thing with the cores of both the Earth and the Sun. The core of the Earth, same like I said, first thing you do is you build you have a theory, something will shatter that theory, you have a new theory. But once you have so many sciences and so many theories that are based off of the way that you understand something to be, it becomes not something that you know, but just something that you uh something that you generally accept because there's no other way that you can explain it. And it's been that way since history. Like we used to think that your soul leaves your body when you sneeze or whatever, like a whole bunch of stuff like that. But then you learn new things. But the Earth and the core of the Earth, there's a lot of properties of it, and a lot of different types of sciences, not just physics, of course, but like the world, like geology, a whole bunch of different types of sciences that would suggest that this is the way that it works. And the same thing goes with the sun.
But see,
Well,
I actually could understand what you're saying about Earth, but I still don't get how you would do it with the sun. Because if it's jumping, let me know. But that's kind of the issue I have with planets, Saturn, Jupiter, all these, especially these gas planets that we can't actually see what's happening. These are just ideas, guesses. Um, I mean, and there's the things that they tell us that just don't make sense, and then can't they don't want to. I don't know if they don't want to, but they don't explain it at all, really. So my question would be, how do they know? Um, I mean, even a team of 1,000 geniuses, I still wouldn't understand how they would know what the core of the sun is, or does, or how it reacts.
well, I didn't, oh, shit, I didn't say it yet. I don't think, but I was gonna say if you look at like the World Poker Tournament or stock market, or it's whoever does successfully over and over, is because these people they work with statistical information. Um, Basically, some things are run on statistics. They're not statistical assumptions, but let's throw out the Big Bang Theory. Let's say the Big Bang Theory is just a placeholder for us not knowing how it started. But let's say that we do have a general idea of how things work in the sense of we know we know how fusion works because we've done it, and so we can extrapolate from that that this fused from this from this, and probably the very first things were just hydrogen. Okay, and so from that, like I said, not really assumptions, but I guess based on how many stars and galaxies we see, we it's a not a bad assumption to make that probably most of what we see is just hydrogen. And so you go off that assumption and you go off that statistics, and you can, and also they do what do they call it, spectrum whatever meters, and they can
Spectrometer.
see what the sun, yes, yeah, there you go, and they can see what the sun's made out of and what Jupiter's made out of, and it actually correlates with their assumption that it's mostly hydrogen, and it's doing this. And so they can also take that, and they can, like I said, they can get a close estimate of the mass, because no one's going to know the exact mass of the sun. They never weighed it, but they use different ways to, they use these different assumptions, which aren't just assumptions. They're like very it's almost like I said, like they're gambling, you know what I mean? And if they're if they're wrong in their assumption, then it's going to be known. Like if someone's like, oh, actually it's mostly iron, there'd be a reason for that, and they would, throw that out and give it that. But it makes a lot of sense that it is mostly hydrogen, and it looks like it's mostly hydrogen, and it looks like it's that size. And so uh, these these aren't just guesses. These are like a lot of information, both collected and then researched on, and then also having nothing contradict it.
Well, doesn't when you say that the corona contradicts that? I mean, the understanding of it.
You mean like the heat of the
Yeah,
corona
yeah,
being
yeah.
less than the core?
No, being
Um,
more. It's
oh, the heat of the corona being more.
yeah. Like they don't like I haven't seen anything that explains why or what.
Where do you? Let me
Um,
see. I
just
gotta.
can I make my own theory for this, just for the sake of argument? Like, you know how the thermosphere on Earth is really hot, apparently.
Yeah. But it's
I'd say this corona being really hot on the sun is about the same as that.
yeah. But see, the difference would be that the Earth isn't a heat source. It's not emitting heat. It's not reacting. It's not the sun. It does. It's not the same thing. That'd be like saying that for everything that we know, yeah, especially from the if you're talking from the core, if you're talking from the core, um, it should, and from what we observe, it should cool down from core to us. It should be a constant cool down. It should, you know what I mean? That makes sense.
I didn't know. I pushed
Yeah.
talk. I thought it was stuck. You
Our
got it.
our biggest scientists have been working at this for years, and we haven't found an answer for this. So, have you got an answer?
Well, no, I mean, I did see. I might have to check it out myself. 'Cause I remember I was reading something earlier today. I couldn't remember if it was about the surface of the sun or if it was about the corona itself. But it said it had something to do with a quantum principle that I might need to check out real quick, just to be sure before I speak on it. But there is some quantum principle. I thought it made it. The thing I read said it made it cooler than expected. But let me find out exactly why it's supposed to be hot.
Yeah, because what the actual knowing of it it's more of what they see in their observations with sorry, on the tip of my tongue. Basically, the filters they use, they're seeing something that appears to be hotter, uh, in comparison to the surface.
Yeah.
But see, that's it. You guys are just kind of justifying why, as a flat earther, I say science is it's not a science. It's a guessing game.
It is a
No,
guessing game,
no.
but
It's
it's a
no,
very
it's a riddle, and no riddle is solved by just making a guess and
I think
that person wins. It's
Sean's
like you.
actual thing of it being a guessing game is quite good, except these guesses are very good guesses. We've looked at everything and it's like, this seems like the best solution to this.
I've read it a little bit, so I'll just go over what I've read so far. And I'll keep reading, but it is talking about the speeds to which they are. Because I've heard, I don't remember. I actually don't remember the time it takes from it to reach the core to the surface. But the speeds that these it's basically like free electrons and um, this type of like photons. Like the speeds of it are of the actual matter is going so fast that when you're talking about heat, that's almost usually what you're talking about is how um how fast is this matter moving. Basically, it's like when you're talking about like the temperature of air, it's like how chaotic and fast is this air moving back and forth toward each other. So
Yeah,
it gives its
kind
heat.
kind of like the
That's kind of
thermosphere. Thermosphere isn't stove hot,
yeah.
but it's
Well, there's no
yeah,
atmosphere there.
yeah. I no, I get what you're saying. I understand the theory behind what you're saying though. I just wanted to say that because a lot of people, because I've talked to a lot of people that will talk about the thermosphere being 3,000 something something, but it's not 3,000 Fahrenheit like we all know Fahrenheit and Celsius to be.
I have no idea how how Fahrenheit ended up in common use. It's like
I don't know.
it doesn't have very
Works.
good 0 and 100.
Yeah, it does. Freezing and not freezing. 32.
He's saying he's talking about. Wait, were you talking about Fahrenheit and Celsius?
Yeah, yeah.
Celsius.
Fahrenheit is just like it makes no sense.
That
Yeah.
does.
Oh, yeah, no,
32 is
Celsius makes
freezing.
sense.
32 is freezing. Anything above it's not.
212 is yeah, no, but those are weird numbers, is what he's saying.
No, I get what he's saying. I mean, I'm happy they did it because you asked me what something is in Celsius. I'm like, what?
That's what he's saying. 0 and 100 makes sense. 32 and 212 don't really.
Same with imperial measurements, right?
There's like King's Foot was 12 feet and this and that.
Well,
Feet and inches
well,
and miles and fuck.
Yeah, let's all just realize that obviously the metric system is smarter. But hey,
Thank you.
But I'm not leaving standard
I
unless
mean, the
unless I'm working on a Honda.
the foot is I find is a better measurement to use for distance than a meter.
Say again?
A foot is a better measurement to use for describing something than a meter because, well,
A meter, there's nothing you can compare to a meter really, but a foot's
a meter can be easily scaled up, but a foot can't really be in the imperial system. So a foot is a better thing to use on its own, but
Right.
meter is better for converting.
Well, you wouldn't use feet. What is it? Something. What the fuck is it called?
furlong.
Some weird thing. I would never use
Looks like
it.
No, we don't
Like
use
Mile,
Or
chain.
tenths.
organs.
Because see, I don't use when in my job I don't use inches or feet, or I guess I use feet, but I use tenths, and tenths are different from inches. I wouldn't honestly. I couldn't give you an exact 3 inches. I can give you 3/10. There's about 4.35, 4.55 inches
I
or
can
something
do
like
3
that.
inches. I can do 3 inches because there's a part of my body I don't want to say, but it just happens to be 3 inches.
I'm so sorry for you.
That's good.
Me
Man.
too.
Yeah, I don't know if y'all heard. What's his name? Lewis's explanation for the subject that I just described, but it's really funny for the reason for bigger and smaller, whatever. But I digress. Let's get back to physics.
The physics of that body part measuring contest.
Yeah, like I said, Lewis had a really funny. Yeah, go ahead. Okay, sorry.
I was just gonna say Lewis has same problems. But I don't want to say that because he won't be my friend. Say. Oh, okay. So, kind of, I get it. I'm kind of get off the sun now because I understand how that works. Um, stay on topic. I mean, I just cut like anomalies type things I wanted to talk about, but I know you kind of wanted to jump around too much.
No. It's not that I don't want to jump around. I think we've kind of. I think we've. We can move somewhere else. We talked about quantum mechanics a little bit, and we've gotten to a place that I don't completely understand because I'm not familiar with
I
that
don't
phenomenon.
understand
But
it at all.
I don't think that it's a mystery though. I think that it is understood, just not by me personally. But yeah, the temperatures both in the core and on the surface, and then on the corona. Like I said, there's guys like Neil deGrasse Tyson, which is like saying Lucifer in these circles. But guys like him understand this stuff. I'm gonna read about it some more, and I might add to it.
Yeah, last 10 seconds.
Actually, I wanted to reiterate what I said because I didn't want anyone to think I was gonna add to the fucking quantum or to astrophysics. But I'm gonna read some more about this stuff, and I'll add to it when it comes up. But we can, if you have another issue or whatever, we can kind of head that way.
Okay. Kind of want to talk about Saturn.
Saturn, that's my favorite planet.
All right,
Apart
perfect.
from Earth.
But then,
It's not my favorite planet. I like Earth a lot, but Saturn's cool.
that intense hurricane going on over there. Wow.
You mean Jupiter?
Yep.
Oh, Saturn. What is it? Saturn.
No, Saturn's got like this. I think it's like at the poles, is it?
It is. I don't know why I brought it up. But
Or is that the big
Well,
thunderstorm?
Saturn has a hexagon on its poles, but
No,
Jupiter
Saturn-
has a storm for the past 300 years.
well, Saturn also hurricane. I think it's about. Got it right in front of me. Changed off it. Goddamn.
Oh, Saturn has auroras.
Okay.
Saturn has auroras.
Lots of plate, yeah. What
So
else?
that means it has to have a big magnet.
Yeah, I mean, it probably has a dynamo similar to the Earth, maybe made out of something else.
Yeah, I've heard a theory that the cause of the magnetic field of Earth is giant molten metal tornadoes
What?
in the
Well,
core.
it's just a dynamo, yeah. The dynamo core.
And I'm like, wow, giant molten metal tornadoes.
Isn't that just like making an accent?
Yes.
Just
Yeah, it's
saying it
it's
out
it's
loud.
not it's the simplest way, which is not necessarily the same thing, but it's the same as an electric motor almost. Not the same as electric motor, but it's the same concept where you have a dynamo and you have something spinning um a different rate than the mass around or the metal around it.
Okay, I found
Yeah, and I've
I
heard
found the
another
notes.
thing that
Hang on. I found the notes. It says Saturn has a massive hurricane. It was reported in 2013. Rotation is 350 miles an hour. Uh,
Ooh.
the eye of the storm is 1,250 miles wide. And the issue that I noticed, and obviously where I got my notes, is that there's zero water on Saturn.
But it's probably a lot of hydrogen.
it could just be in another gas other than water.
But but okay, well, the issue would be, I guess, from everything we know of hurricanes, it doesn't make sense.
I'd say it does because from my understanding of hurricanes, I'm not saying this is correct. It's just caused by a temperature difference,
So the same.
and then there's a lot of complex aerodynamics involved, and it's just a temperature difference that causes it.
So you're saying a tornado then?
Well,
Well,
they
a
use
tornado
words
and
like,
a hurricane.
Say again?
yeah, they use these words.
I'm
They
not
use-
an expert on it. I'm not saying I'm an expert on it, but that's just my basic understanding.
The hurricane and tornado, the key fundamentals of them, one is warm water, the other is air.
Yeah, but a
So
cyclone and a
But you
hurricane.
should have something that I'm pretty sure that the warm water just makes it so it's just a big thing that produces heat, basically. So you could just have like a warmer layer of air instead. I think.
then you're talking a tornado, water spout, or I mean,
So like warm ground instead, like a desert, and then you could get a hurricane maybe.
nope, you can't have
Oh,
a
you
hurricane.
can get a sandstorm from just that.
Yeah, but that's a tornado.
That's a dust devil, I'm pretty sure. Like
Yeah, but
Yeah, but
it's
these
a
are all
form of tornadoes.
yeah, but these are all semantics because it's like they
I'm just
are.
gonna look it up. So it's like
Yeah.
I'm gonna.
Hang on.
Wait, what are you saying about them being? They're fundamentally the same thing, but the reason they're called different things is because they take place in different locations. They're
Yeah.
made out of different things, but the physical features of them are or the physical like the reasons behind them, the mechanics of
Oh
these
no!
are the same.
Help! I've just discovered a website that explains it very well, but it's written in Comic Sans.
I have no idea what that.
That's the second time tonight you said you couldn't read two things that you should be
It's
able to
Comic
read.
Sans. Do you not know how bad Comic Sans is?
And you
It's
should
pretty bad. Is it as bad as your handwriting? Or worse?
Slightly worse.
share the link in the chat, please.
Your eyes will bleed.
I forgot that you're my New Zealand guy, my New Zealand buddy. I love New Zealand. I've never been there, but so many Australians online that just forget.
It's written in Comic Sans. I'm dying.
Come on,
Yeah,
man.
so
This is
so
like
basically,
this is easy.
can't have a tropical depression land. That's kind of the theory of why they dissipate once they hit land.
Because the water, it's two different mediums almost.
Here's a picture I found. Just a random picture I found when I looked it up. So I think the Coriolis effect would cause the spinning, and it just says warm surface, so air rises, and then the Coriolis effect causes it to spin, and yeah.
I mean, honestly, the way I think about storms, I always tell people, dude. I tell them Well, anyways, the way I think about weather is you can predict the weather just by just checking out the wind because the wind is going to be like he's saying the temperature is changing and they're not they're not. It's not the same temperature in different places, and so that's going to be
I'm
the
gonna have to go
fluctuation
now.
of the air moving, and so they're going to go up and down. And I guess due to, like he's saying, due to the Coriolis effect, they're going to be wanting to make a spin. Where if there was no Coriolis effect, it'd probably just be just rushing around in random directions. And this could happen, I guess, in any spinning object. At any
Well,
place.
okay. So now, um, can you find one
I'm gonna-
for how tornadoes are made? Because they're two different things. I mean, or Coastal, you understand what I'm saying? It's they
Oh
I
yeah,
they
remember seeing a graphic of it, and it was
the hot it's
2 layers of opposing air going in different way
gliding
times
basically.
one above the other, and it creates like a funnel
That's
thing. And for some reason, it goes up the other way and then starts going around.
it's when the cold front and a high front heat waves whatever collide
Yeah, so like one goes underneath the other, and it makes like a tube thing, but then it goes upright somehow.
because it's like a top. Uh, start if you start slow, that's the collision. Faster you pull that top, like Kosa, the cradle. It's just the effect. The high pressure. It's just same thing, high pressure, low pressure, but it's kind of like you ever seen square dancing?
No.
Or
it's the worst question to ask him.
I know, I don't even know why I did.
No, but I posted a picture of one diagram, but exactly like you said, yeah, cold air, warm air,
Yeah,
them colliding.
I thought it was like they collided and then it made a tube like horizontal to the ground,
it's no.
and then that just
That's right.
somehow went upright.
Imagine it this way: they can't they can't collide and mix, so they have to go around each other. But when they go
Ah,
around each other, it's kind of like see, there's 100 ways I could explain it, but I know you wouldn't
No,
understand.
you're right. It's just like you're saying, like a square dance or any
Yeah.
kind of dances or any. If you ever seen a horrible accident, even
Yes.
not that you ever seen it, but like a head-on collision.
Cars
Sometimes they'll
turn.
crash right into each other, but if they twist around each other a little bit because they're crashing, but
yep, I get it now.
Okay, but
I
yeah,
get it.
but it's because it's the air, it's a force that
So
can
if they're like
continue
not
itself.
directly crashing into each other, they create a twisting force.
right.
Yes, they have to go around each other. They can't go through each other,
Okay.
and kind of
But it
pulls each
still
other into
is
it.
a vertical collision, but there's also horizontal collisions, which is the wind. But there is still a vertical collision because it's still going to be warm air rising, the cold air dropping.
And then also a hurricane. There's a huge difference between because think a hurricane works the same way as a tornado, but realistically, a hurricane isn't the twisting effect. It's the wind. It is the weather. It is not. It's not a tornado effect.
But
Um,
tornadoes are weather.
it's not the same exact thing, but it really is.
This
I
is
mean,
like
like you said,
one is
The Coriolis has a lot to do with it.
You're not going to get a
it's
funnel
like
out of a
one is
hurricane,
like
so to
from your
speak.
definition, I'm getting that like one is from colliding things causing a twisting force, and the other one's from the Coriolis effect.
I would say
They're-
more of a pressure effect.
Okay.
A hurricane would be more like if you push down, like explanation. I don't even know catch. You had a bucket and you had like a plunger, plunged it down in. The way that water compresses itself, comes up around the sides. It's the same way a hurricane works. So it's cold, it's the air condensing down, and then the warm air of the water that's above the water, rushing up to the top, sitting on top of the cold air. That's what makes that hurricane shift. That's what makes that twist. Kind of like if you got a 2 liter bottle, that fun little game you play in school, make a tornado.
Uh,
But go get a 2 liter bottle, fill it 3/4 or halfway up,
oh,
spin
yep,
it.
by spinning it round.
Yeah, okay. Well, that's
We did that in the pool.
yeah, that's a tornado. Well, if you try to squeeze the top of that the 2 liter down, won't be able to, but if you were able to squash it to the ground, everything would displace itself like a hurricane takes that big wide area, and then the cap, eye. So a hurricane,
Okay.
so
So like this for hurricanes.
exactly. So like a hurricane, the system is like a tornado, but it doesn't act like a tornado.
Mm. So basically, it's warm air rising, and the convection currents are going with the Coriolis effect, and it's rising up, and the Coriolis effect is causing it to spin,
But
and it makes it
you're saying, okay,
a hurricane.
I don't think the chorus. Well, I know it doesn't, because if you look at where the oceans are and everything, you don't get hurricanes south of the hemisphere like people make it seem like
Yeah,
it
we do.
happens.
We get typhoons,
Exactly,
which are
they're different,
hurricanes
but
that revolve the other way.
it's also
Yeah, they're the same thing.
yeah. But see, the thing is,
They revolve
one
the other
is
way.
a much larger scale.
Maybe because
No,
the ocean.
we get
Look at
pretty
any
big ones down here too.
look at any
The one that sunk the Wahine, that was massive.
massive to who,
Us.
because we as
That
far as
was strong winds here in Wellington, and we're used to like 200 kilometer an hour winds. Yeah, I just
kilometer,
choked on this. That's like 120 miles an hour. We're used to that sort of wind here in Wellington.
because I've read many of tornado articles, all the different the same. That's like saying tornado or hurricane or tornadoes happen in like the Arctic area. Or I'm sorry, hurricanes would happen there. Find it. I actually do have clock rotation. So meteorologists have tornadoes, cyclones, hurricanes can have a rotate in both directions, as well as dirt devils, water spouts, stream devils. My source, I have no clue. I took those literally. But yeah, look it up. My notes are from a
Okay, I
meteorologist.
got it wrong. It's a cyclone. It happens on the southern hemisphere.
Article. God damn it. Outsource, you're about to get fired, you dickhead.
What?
The outsource.
Veritas.
Yes, outsource. All right. What happened to that? All right. Let me see if I can find this. I'm gonna try to see if I can find a link.
Okay, well, I just if there's something else, I was just reading about it a little bit, and yeah, it doesn't seem really that. It doesn't seem. I don't know what the issue is with this one, because actually there is water vapor that it's also using, that it takes from the atmosphere, and they work almost
Talk about.
on Saturn.
Okay, thank you. Yeah,
There
I was
is still water vapor that it's using from close to its.
I found a source of
hang on.
information.
You can't keep cutting them off. I'm cutting them off right in the middle of the explanation.
Saying they work. They're less like tornadoes and hurricanes are to each other, and they're more actually just like hurricanes. Like it's just like a hurricane where it actually uses the water vapor to get stronger, and it is mostly using the hydrogen to actually work. But there's water vapor involved, that actually where it's getting most of its energy from. That it's getting from its like from the higher atmosphere,
I
and it
thought
actually is going close to the south. It's going towards the South Pole because of the Coriolis effect, similar to those hurricanes on our planet.
so. They do say that there's hydrogen, or that's what's fueling it.
What there's water? It's because the planet, I'm sure, is mostly hydrogen. I have to check, but I'm certain almost. But there is water vapor that it is using to fuel up and continue. It's not like what I found, but to find it.
Okay,
I got a
found
back sheet. Like,
I found some information on hurricanes and typhoons and cyclones. They're all rotating storms spawned in the tropics. As a group, they can be referred to as tropical cyclones. But because of the Coriolis effect, these storms rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere.
They tend to.
Okay.
I'm sorry, I'm about the. I just put the link in.
Yeah, it's a stupid because that's the one I read that
Okay,
I found that
okay.
information, but it just has only that one piece of information. It's like, oh, fact sheet. Well,
Yeah.
there's only one fact in it.
It's a long bunch of little paragraphs saying the same shit.
And it does say one part about the hydrogen and the fucking.
Yeah, down. That's where I'm at right now.
Um,
Okay. I was like, it said
fourth
something.
paragraph. In the fourth paragraph.
Oh, hurricane. Ocean waters on Earth. Up, yet there's a large body of water. Saturn, however, off with water vapor atmosphere.
I bet you that small amount of water vapor is probably still more than our fresh water here on Earth.
It probably is.
And also, their water vapor there is considered way. It's not that it's heavier in itself, but it's heavy compared to the gases that it's chilling with, like the hydrogen and the oxygen or whatever the fuck else is there, but the hydrogen mainly. So it's like the storm. It's easier to rage like that. I don't know how that water vapor is compared to our atmosphere, but it's just way bigger difference I'm seeing.
Page won't.
Hydrogen and
Space.
helium, of course.
Hydrogen. Atmosphere.
Probably a lot.
Got some.
Yeah. I mean, how do they figure that stuff out? How much hydrogen it's got in its atmosphere?
That is what I've been trying to ask.
Ah.
What question?
How they know these things? Can't.
No, I
Like
mean
how much hydrogen's in Saturn's atmosphere?
they use spectra, whatever they call that, and then they also use I mean, like I said, they'll get data and they may be off. Like when they first got this data, it was like 300 years ago. So it's like they get data and then they find something new else out, and then they change the data.
I think Veritas is going to get banned soon.
I doubt it.
Oh, is he going to get fired?
Well, gets fired. This server's gone.
Oh,
I can't figure this shit out. Told you, man. He's my outsource.
Veritas, why don't you?
Then there's what I'm reading right now. They're talking about how Saturns are the reason hydrogen in the atmosphere.
What?
Gassers of Saturn's gushing jet of ice, gas, South Pole, contained molecular hydrogen, chemical hydroactivity
Hmm. That's interesting.
provides fuel. How far are the moon? How far do they are?
What are you, does it actually say that the hydrogen comes from there?
Journal of Science that jets of ice and gas, South Pole, molecular hydrogen.
That's probably where the water comes from then.
Yeah, that's what I meant.
Because say that the hydrogen's probably you know, besides it on Earth not being the main gas, it's probably very likely that it's the main gas on all the gas giants.
Well, they're saying that the hydrogen is giving the hurricane energy.
Water vapor.
Well,
On the ice.
mix of hydrogen and oxygen.
Yeah, but the water, that's
Oxygen.
different than the hydrogen that's already sitting there on all over the planet.
A combination of hydrogen and oxygen, isn't that what makes up water? H2O?
Yeah, but it's not that they're chilling together normally. It's like that's what he's saying is that water vapor is coming from these moons, which shoots it onto the top part of the atmosphere, which then is sinks to the lower part of the atmosphere, which is what causes some of these storms to happen. But the hydrogen itself is just really chilling there.
Did we answer the question of how they find out the composition of Saturn's atmosphere?
He said that.
Oh, look,
they have
that
a
picture was taken on my birthday in 2011. Yes.
I want to read this because now I'm all of a sudden seeing an article that's talking about the oceans of Saturn.
That's new. I'm going to read that.
Yeah, but it might not mean ocean like that.
Yeah, no. Same thing, probably the same thing we're talking about.
Well, you can consider the atmosphere an ocean. Our atmosphere on Earth is basically like ocean.
It probably wouldn't be liquid water. It would probably be like liquid hydrogen or something. Because if all the water's coming from the moons, it wouldn't really be that much to make an ocean.
Yeah, see, there's all about the ocean on Saturn. Content.
Ingredients for what?
No. All known contains known. Okay.
Okay.
See what type of things I look at and go.
Oh.
Saturn's. And now scientists waters a life. Yeah, come on. Oh, now we're gonna go live on fucking Saturn.
This is Europa.
Europa, they made a movie about that Europa Report. But that just means that
No,
there's
it's
ice
Enceladus,
there's
sorry.
water. Yeah, Enceladus too, though. But Europa specifically, as on Saturn's moon, I think it's because there's an ocean of water underneath an icy surface, and there possibly
So
could be life.
basically,
But
So basically, what they're saying is there might be life there, like microbes and stuff.
And they could have, yeah, it's like successfully.
They found all the ingredients for it, so
I wouldn't say that.
I've heard that theorized before, but they don't have evidence. But they can very much find it. It's not impossible.
Yeah, isn't the
So
temperature like below blah 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 blah?
Yeah, on some places, but also closer to the like. There's water. There's water there. There's water
There-
underneath the ice.
Yeah, but that doesn't mean
scientists say its waters may possess life-sustaining features as seen only on Earth.
And like we were saying about Celsius, 0 through 100 Celsius is basically, I would consider that. I mean, there's a Goldilocks zone of where the distance from the star, but the Goldilocks zone, as far as temperature, would be between 0 and 100
it
Celsius.
says
Liquid water.
an average temperature of minus 208 Fahrenheit.
That's the surface though of the moon. But I'm saying underneath the rocky.
No, this is Saturn.
Okay.
Saturn is
I was
a
talking
pretty
about
cool planet, although there are some small different levels. Much
I'm
of
gonna have to
Saturn's
go now.
temperature
buddy.
is. I don't know. Have it going. Kind of weather does.
Hurricanes. Fucking giant ones.
Hurricanes and tornadoes.
So,
Oh, you can't have tornadoes without land.
Don't know.
yeah. It's all the same thing. Though. Same difference.
Not.
They're not exactly the same thing, but just like when you flush a toilet or when you let things go down the drain and things are twisting, it's like a twisting thing. It's a twisting fucking thing.
Please
It's all the same.
don't go to an elementary school playing that way.
No, but I mean, just because it's on a different planet or if it's over land or it's this, of course, you have different names to classify them. But the same way, like I was saying about cyclones and hurricanes, they're not they're not exactly the same thing because they're taking place in different places and have different properties, mainly just the direction of the spin and size, but they're generally the same thing. But the ones on this planet are, the ones on Saturn were basically very similar to the ones on Earth. They're just there's different things that cause it, but they have the same mechanical properties. But other than we can still mess around with Saturn and stuff, but yeah, but I mean like I guess I don't know if you took other notes or something.
Oh, damn. Another. Perhaps the only similarity contain cause damage. Differences between parent storm. Um, you shouldn't.
I want you to fucking flat slap me, man. Flat smack me.
Flat bitch.
Give me one of those. Give me one of those.
It's flat. I don't know what to fucking tell you.
You just said it.
Flat. That's what it is. Science is confused. Waiting to find out it's flat too. But that's what I get from.
Yeah, but science is always happy to find new things out.
Yeah. Kind of like science would want to let everyone know they figured out how to control weather, but
I think science has. I mean, these papers are out. The information's out. It's just the news.
magnitude.
It's not presented on the news, I guess. But
magnitude. Cloud seeding. Cloud seeding count.
Yeah, military findings they don't like to present as well. But the science itself, technology, it's not entirely hidden. Like I said, the engineering usually will be, but
Everything.
by the way,
the real weather model. Real. I'm talking fuck seeding and fuck the atmosphere or fuck the ionosphere. Going bigger than that. Much higher. Everything.
Yeah. Well then,
but they're not going to say anything. I mean, just 2 reports alone. One, they want to control a government by 2025. They have a control weather by 2030 plan.
There you go. But yeah, we've been stuck on Saturn for all this time. I've been sitting in the car, just chilling. Ate that burger, but maybe there's another thing. I guess I'm biased because I really like quantum mechanics and it's just always fascinating stuff. And maybe I should have just been checking that out while we were talking. But I'm really fascinated by quantum mechanics. I guess it's because it seems magical, you know.
Basically,
Seems like stuff.
that's it. It almost seems like anything try to research up leading to.
No, it's not. No, it's not. That's the thing, though. It's not too complex to even understand. It's just too.
This is added stuff. To me, I understand how I have a better understanding than relativity.
Okay.
Well, that's
What do you mean? What does
well,
that mean, though?
well to
You think you understand?
I'm
Understand? You understand?
sorry, go ahead.
No, I was just saying, I don't understand what you're saying. Like it's you understand the theory better than
No.
relativity.
I understand quantum, like the quantum field details, more than
I
I
see what you're
understand.
saying.
Yeah.
It seems what you're saying is it seems more realistic than
Yes,
relativity.
absolutely.
And actually, like I said, I've been thinking a lot the past couple of days about specifically time dilation. I've been talking about it a lot, and we were talking about metaphysical stuff and the nature of the universe and God and simulation theory and these things. And the truth is, you know, everybody has different religions, and you may not have one, but I mean, I believe that the universe is one thing, one whole thing, and it has one spirit in it. But I believe that that spirit is only capable of manipulating and observing it through real like the senses we have and the senses that trees have and the senses that these things have. Like wind doesn't necessarily have a sense. It just moves along with the forces and stuff like that. And so what I'm getting at is that with time dilation, the big what do you call that? Paradoxes of time dilation and relativity is, you know, that time is subjective, meaning that it's relative to only the observer. And the example they usually give is the one we talked about last time with the twin paradox, and two twins experiencing time at different rates to such extreme amount that life. So I'll give you an actual calculation I did the other day, but
Well, they
like if you were going 99.99,
NASA
huh?
had did that test, and
Yeah, they did that test. They do it. They use that with technology every day. We're using it. I'm using it right
well,
now to
no,
use
no,
this marker.
they had a twin, or one of the astronauts was a twin, and back after a year, they're I don't want to
Yeah,
give a
they were
it's
testing something else though.
no, well, their genetic structure, they're no longer
Yeah, exactly.
genetics.
They were testing for like the difference in stuff like radiation and stuff like the bone. Like they were looking for basic tests that they could that two like you could that you have two twins that had the same almost the same DNA and the exact same everything else and measuring that. But the time dilation itself has been measured way before then. And I was calculating even on an airplane there's time dilation, but they're so small that it's not gonna. There's no reason to even
No.
consider it.
Their genetic chemistry is changed. They are no longer.
No, I know that. I know. That's what I'm saying. That's testing something else. It's not necessarily testing the
Oh,
time difference.
okay, yeah, okay. I
The
see what you're saying. My bad.
time dilation is like they did experience time differently, but it's still such it's negligible. I can't even make up a number right now, but I was looking yesterday, and like an airplane, if you travel millionth of a second difference that you would be, and so that, yeah, you know what I mean. So you'd have
Yeah.
to you'd have to make a million flights like that for it to be even a second difference.
Yeah, this was a their
But
test was on gene expressions. Gene expression.
yeah, right. But what was it? But yeah, if you were traveling 9.99 for however length of time, let's say 1 year, you would then be what was it? Actually, no, but that's right. Okay, so if you were traveling for 1 year, it would actually be like 100 years later for everybody who wasn't traveling at that speed. And so then that rate, you would definitely experience a difference in time. But even this idea that like there's not an objective rate, there's not an objective frame of time, there's no objective reference, and that I really kind of boggles your mind because you're like, wait a minute, so there's not a measurement you can make, like there's not a clock you can keep. They'll actually have one time. Me and Gaylord had talked about this, and he says things like, just because you're going this speed, that's going to change the speed that we go around the sun, because that's how we measure time, is our spin of our planet and the spin around the sun. And it's not that those things are slowing down or speeding up. It's just that through the eyes of and the way time is experienced. It's just, I mean, it is weird as fuck, but it has to be true because it's been measured to be true, and we engineer things um, using this thing that we believe to be true, and it gets us places precisely. Like Alting is traveling all the time, and he probably uses GPS every so often, and GPS
Basically, yeah.
uses atomic clocks, which have to put that they're traveling in space and crap, and so yeah, no, yeah. Just going back to what we were saying, that's both those theories, quantum field theory and general relativity, special relativity. It's all weird stuff, but that's the point that we are in. Is like people always think like one day we'll know everything almost, or one day we'll understand maybe what God is, or whatever the hell. It's weird to use God and hell in the same sense, but whatever is going on,
That's just
we're at that point
using
where
those two
it's
words
past
is
what
the same
we
thing to me as using gravity.
observe. Yeah, but gravity's a real. It's a real. Like it's like it truly is the relationship that mass has with space time. Like that's really all it is. It's just describing the relationship, or the relationship between mass and space time, and the effect that mass has on space time. And they say it warps it, and yeah, it just it changes it at a rate at a rate equal to its mass. So greater mass, the bigger warp of space time.
That also does that mean center of our galaxy younger? No. Yeah,
Uh,
younger than us.
it's not okay. So the center of our galaxy actually would have everything from our frame of mind, and actually, like the way we see time is through light and how far we can see it. And so we say 13.8 billion years. But if you were for some reason alive at the center of the supermassive black hole in the middle of the galaxy, yeah, you could have been like a baby born, who knows how long ago, and time would have been going so much. It's supposed to be going faster. So yeah, it's yeah. I forget. I always forget which one is which, but yeah. So they would be. You could be like young as fuck, like a million years ago or something like that, and time would have gone. Time would have gone so much faster all around you. So as time goes faster, that's right. So time slows down as you're closer to the core, and so yeah, you would be younger, and that's what's weird.
That would mean that our galaxy younger
Like I said, that's why it's a paradox. That's what I'm saying. Is it's not something like the way that you're explaining it is the way it's not wrong, because the way
no.
anybody would explain anything is that there's a universal reference
Yeah,
of time.
yeah.
And that's what I'm saying is there's not, and then it's really confusing, and it's really, and I'm not saying no one knows what is this that's happening, but it's just that seems to be what the truth is that there is no
No, see, I get it, and I phrased it that way on purpose. The issue I have is with all the things that we are they too
understand or know or rise. The realization is that 5% is a very, that's all science has a about space.
Yeah, dude, that's a lot, dude.
No, no,
Even though it's 5%,
that's
that's
a
like
little
no, dude. Dude. I mean, even okay,
compared to
that
the
is that's
size, yeah. But
there's 95% of unamounted if you count both of black dark. I'm sorry, dark energy and dark matter. That would account for 95% or 96 whatever it is percent of everything else. But yeah, even just knowing that, dude, we've come a long way. Even just understanding that, and so it's not to say we're done and we give up. It just means that there's dudes every day who are trying to make shit up, and they're probably almost all going to be wrong. Um, yeah, it's just like given time, if you allow people to keep learning and you allow these riddles to I want to say people like me, but I'm not a smart guy, as I'm saying. I like to solve puzzles, though. I like to solve riddles, and there's always people who are just trying to solve these riddles, and they'll keep on they'll keep on doing it until they figure it out, and they'll keep on. They have like machines. It's not like they're giving up or they're people are destroying the machines. They're getting bigger machines and better machines, and they're eventually going to find out. Um, like dark matter and dark energy. That's why I don't like to use that 4% or the fact that it's matter that we don't know or gravities, because those are all also assumptions. Basically, the measurements are off, and that's due to something we don't understand, and we'll figure that out. It could be that there's a fifth force. Who knows? There's a fifth force. Probably not, but maybe there is. Who knows?
there
A bit.
I don't like you.
Well, no, I mean, no.
I know. I'm just
That's the thing. Oh yeah. Well, yeah. And by the way, I was reading quantum field theory early on in the conversation, and it was saying that it, like, reintroduces ether basically into the equation. So I've always even when I started learning about all the theories that flat Earth people have, I even wondered if possibly ether does get reintroduced in a way that's not like first of all, people claim that like people use ether to make their equation. Someone told me Tesla used ether in every one of his theory. He did not use ether. He fucking he thought ether was real, but he did not use it to make anything.
even better than that. Ether isn't. A lot of people like this shit. It's just talking about earlier. It's something. It's just
Well,
something
yeah, but
there.
it's just like space time. I mean,
Yeah.
space time is just something, and it's like what if they're the same thing? But then they say they met people assume ether had mass or something like that, and ether is really just a word. It's not. It
Yeah.
doesn't describe anything because no one's
It's a description
measured it or
of
seen it.
something out there, rather than
Yeah.
it being a void of nothing. Something. That's all it really. Not a
Yeah, just
monster.
kind of like. Well, yeah, but same thing. Well, dark matter and dark energy are even less than that. They're just words that just basically they're placeholders. Like I said, I don't know if I brought this up to you before, but X-ray is another placeholder. And there's a couple other things that were named the same way, where like they called it X-rays and things like that because they were not known. It wasn't known what this thing was or what was going on, and then they found out, and the name just kept. That might happen with dark matter, dark energy. It's just there it is. Don't know what it is. They don't know what's going on. So they fucking put that there. It's also kind of like the universal constant that Einstein had. Like it didn't change everything else. It just he added that in uh assumptively, and turns out he didn't need it. Took it out. Or
I can now. How far around that corner go before it comes off the rails? It doesn't make I get quantum. It's not. It's not enough of this compared like that, but at the same time, 50, 600 years from now, they're rocking with the quantum. It's gonna change a shit ton of stuff.
yeah, it might, but it's also like if you were like inside of a house and like you live next to a highway or something. Let's just say, and you never looked outside the house, but you always heard like the rumbling of the cars outside the house, and then you also like let's say you're a baby, and so this is your experience, and then you also sometimes or a dog even, and let's say also sometimes you're the owner came home with the keys, and they, the car was there and it wasn't there before. And say other times you were going to the vet and you were in the car. And so like these are like experiencing the same thing, but they probably don't understand what the difference is. But there are three different ways of describing the same things that are going on. And that's really the problem with quantum field theory and gravity and all that is there was just two completely different ways of describing of like I said, they know there's four forces. They don't know about a fifth force. They know about these four forces, and three of them do fit into one theory, but the other one was just it came up in such a way that it didn't quantum mechanics wasn't even a thing. And so you're right to say that they could completely change, but it would not change our understanding of it. It would change these papers that are trying to make a picture of what's happening, when truly what's done is science uses the measurements, and especially engineers use the measurements of what they're meant to what's meant to happen. Like if you ask a kid what gravity is, people even say it wrong when they say it's mass attracts mass, but the truth is it's mass's relationship to space-time. Mass is warping space-time proportionate to its mass. But most people would say gravity, like you say, prove gravity, and they will say something falling to the ground. And so, real people don't use this actual, these like the standard model of the paper, but they know all the mechanics of it. And so all those mechanics, none of them are going to change. I think that we'll just have a wider view. And like I said, the parts that don't come together are parts that are way outside of our realm. Now, it'll be cool if things like dark matter and dark energy actually have giant consequences here on Earth, and we can use those consequences to, manipulate and change shit. But mostly, not most likely, but it could also be that they don't, and that there's just something else going on out there, and who knows, man.
I get it.
Who knows?
All right. Hey, I'm not gonna call it a night. Kind of hungry.
There you go.
Got to get my smoke.
Yeah, and
I'm gonna end this. I mean, we can like have conversation.
Oh, that's cool.
So I'm gonna then something, and then I'll hit you up, and then
I'll either be in here or you were just in my other server. I might be in my server listening to music, but if not, then I'll be here.
All right, yeah. If you're not here, I'll head over there. No problem.
Cool, man. Awesome.
Combo, man.
Yeah, of course, man.
Talk to you in a little bit.
All right, cool.
And that is it. Like I said, it was a debate. Possibly not a heated like sorry, but like I said, hype dates that will happen. Huh?
The hustle standing, flag no fail. Hold strong, people. Hold strong. Revolutionary, frontline standing, solitary. Mind state, kinda scary. Take a deep breath. Take a deep breath and put me on the front line. 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 Hold strong. I'm battle tested. Hold strong. I'm battle tested. Hold strong. I'm battle tested. I'm battle tested. I'm battle tested. Hold strong. I'm battle tested. Hold strong. Follow me until the end. Follow me if you can. Heart beating faster. Don't forget to breathe and put me on the front line. 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 Hold strong.
Goes out to every armor soldier. Left, right. We are the frontline soldiers. Anything that happens, we gon' jump first. When everything is over, we still gotta go back. Shout one more time. We are the frontline soldiers.